So now I'd like to introduce our next speaker, David Mahler. David is the founder and leader of the Marin Sonoma Building Electrification Squad and the Larkspur Climate Group. And he's going to tell us all about heating, cooling, and breathing easy with heat pumps. Welcome, David.
All right, so I'm just trying to share my screen here so we can get going. Let's see. That should do it. Can you see my screen okay?
We can. Thank you.
Okay, perfect. Greetings, everyone. I'm glad to have this opportunity. And what I'm going to do here is sort of address the question. So you want to install a heat pump. And I'm going to try and take you from the point where you first start thinking about that to the time that you would actually retain a contractor. I get asked this question all the time, and so that's what this presentation tries to address. So you want to install a heat pump, great. As we've already heard, use of fossil gas, which is methane in buildings, produces about 1/4 of our greenhouse gas emissions. And as we've also heard, leakage all along that use process really increases the impact much more. And what hasn't been touched is fossil gas really poses serious public safety and indoor air quality risks. So it really is worth moving away from this, changing out your gas fueled, especially space and water heaters for high efficiency electric heat pump models really is one of the best things you can do to reduce your greenhouse gas emissions. My presentation focuses primarily on heat pump space heaters, though I'll touch on water heaters as well. And one caveat, the presentation focuses on air-sourced heat pumps that use ambient air as their source. And you'll see as I go through this, I've written this out pretty completely because I want everyone to have access to these slides afterwards so you don't have to take notes and you can look at this as you make your decision. So what is a heat pump? Well, it's an electric power device that transfers heat from one place to the other. It does this using a compressed gas that expands as it moves through heat exchangers, and then fans transfer the heat from the heat exchanger to the air. Heat pumps are not a new technology, but they've recently gotten a lot more efficient and advanced. And this is actually a technology that you're familiar with. It's in your refrigerator. It's cold in your refrigerator because a heat pump is extracting heat from the air inside your refrigerator, and it's discharging that heat into your kitchen. A heat pump space heater does work the same way, but in that case, it's extracting heat from the ambient air outside your home and discharging that heat into your home as warm air. And modern variable speed pumps, space and water heaters are many more times efficient than even the most efficient gas heaters, because they only have to extract heat from the ambient air rather than having to create the heat by burning fossil gas. So this is a diagram of a heat pump. I'm not going to go through this. You can look at it in the slides later if you're interested. But there are two basic types of heat pump space heating systems. One is called typically a central ducted system. And this is a system that uses your existing duct system and a single indoor heat exchanger to move heated air inside your home. And then there's what should be called, and is technically called, a ductless system, but it's often called a mini split system. And this system does not use existing ducts, and instead it uses hoses to pipe the refrigerant to local heat exchangers at multiple locations inside your home to deliver heat to those locations. And you saw, I think it was Bob Brown, talked about that kind of system in his house. And sometimes the two systems are combined. So you could have a ducted system for part of your house, and you could have a ductless system for another part of your house. So why would you use one of the systems or the other? Well, if you have ducts and they are large enough and in good condition, a central ducted system is going to be significantly less costly. But if your home doesn't have ducts or has duct issues, like they leak, for example, or they're too small, a mini split ductless system is likely the way you want to go. The ductless system also gives you the advantage of temperature control at multiple locations, but it's more costly due to the multiple heat exchangers and the longer refrigerant hoses. So the principal components of a heat pump system, there's two components. One component is located outside the house, and you saw this in some of the picture. It's generally referred to as the heat pump. It consists of a compressor and a heat exchanger. The other component is located indoors, and that consists of one or more fans and heat exchangers. So in the central ducted system, that indoor unit is called an air exchanger and is typically located close to the outdoor unit. And the two are connected by short refrigerant hoses. For a ductless mini split system, the indoor units are typically called wall heads, but you saw they can be in different configurations, and they can be located far from the outdoor unit. And each wall head acts like a small air handler and is connected to the outdoor unit by longer refrigerant lines. And you saw that in the first home. You saw those refrigerant lines. In my presentation, I have diagrams of the two different systems. I'm not going to go through those right now, but you can take a look at them later, both a ductless and a ducted system. So what about the performance and comfort of a heat pump space heater? Well, the way a heat pump system warms your home is different than the way a conventional gas furnace does. So the gas furnace puts out periodic blasts of very hot air, about over 100 degrees, and it turns on and off a lot. And the air temperature in your home fluctuates with each cycle of the furnace turning on and off. And that on and off cycling is also hard on the equipment and prevents the equipment from operating at its maximum efficiency. In contrast, a heat pump space heater pulls warm air out of the ambient air and puts out the warm air almost continuously, running at variable speeds to maintain the temperature that you set on your thermostat. So it's more of a wash of warm air, which heats up the interior surfaces of your home, as well as the indoor air, and results in very steady temperatures. And I heard this along the route. The difference between a gas burning and heat pump space heater is the difference between having a bucket of extremely hot water thrown at you periodically versus taking a long warm shower. And here's sort of a magic thing here. A heat pump space heater also can cool your home. So the heat pump system, when you look at that diagram, can be run in either direction. And so the same way it extracts heat from the ambient air and puts it into your house, it can extract heat from inside your house and put it outside, just like the inside of your refrigerator. So you get air conditioning for free. So if you're thinking of air conditioning, a heat pump gets you both. So what are your options for heat pump water heating? Well, heat pump water heaters are here, and they're being improved all the time. You saw in the previous presentation some examples of it. They work using the same principles as the heat pump space heater, but the heat is being transferred to the water rather than the air. And they're available in different sizes. And fortunately, you may be able to get a size that you can simply swap out for your current tank type hot water heater. Will switching to a heat pump increase your electric usage? Yes, you will use more electricity, but you'll use less gas. And since an electric heat pump space heater is at least 3 or 4 times more efficient than even the most efficient gas space heaters, your overall energy costs, gas plus electric, should be less. And one other thing to keep in mind, the reason to convert is really to cut greenhouse gas emissions, and that's worth a lot. So what about when the electricity goes out? I get asked this question all the time. Well, for space heating, there's really no difference. With the electricity out, the fan of your forced air furnace isn't going to work anyway. It's true that older tank type gas water heaters will run when the electricity is out, but that also means they're pumping greenhouse gases into our atmosphere all that time when the electricity is on. So where do you start? Well, first you want to check the energy efficiency of your home with an energy audit. You'll also want to get a duct leakage test to see if you have ducts, what the condition they're in. And it may turn out that you're going to need to do other energy work for your house, adding insulation, fixing duct leakage, and so on to make your heat pump work well. So where can you get help? There are very good resources available. They're listed here: Electrify Marin, Bayrin, and the Switch is on. Their websites are here. Each of these sources provides guidance, consultation, contractor names, and other references. So these are just tremendous resources, and I would check out all 3 of them. So why not just call up your HVAC contractor and or a plumber? Well, the problem is most HVAC contractors and plumbers are really not very familiar with heat pump technology. And they'll probably try and talk you into installing a gas unit because that's what they know how to do. I've listed some reasons why they might do that. You can look through those later. And if you insist on a heat pump model from a contractor that really isn't familiar with the technology, you may not end up with a great installation. A few things to watch for with HVAC contractors. A lot of times if a client insists on a heat pump, they'll recommend getting a dual fuel gas and heat pump for a backup burner. You don't need that in our mild climate. And even contractors who are familiar with heat pumps often really recommend the ductless systems. And so that's something to watch out too. It may be that your ducted system will work just fine. So the issue of electric capacity, that's a good one. And we've already talked a little bit about electric capacity, but it really depends, on what your current electric meter, your electric panels capacity is and what your load is. Almost for sure, you'll have to run a new electric circuit to a heat pump space heater. Typically not a big deal. If your electric service is 200 amps or more, you'll probably have adequate capacity. If your electric service is 100 amps or less, there's a good chance you're going to have to upgrade your panel, and that can be expensive. You need someone to assess your electrical capacity. That's an electrician. Also, there's a new company called Ready, Set, Replace that can help you do that. It's a good idea.
David,
Yeah.
Hi, this is Amy. We're going to have to move along with the program. Is there a good stopping place pretty soon?
Yes. I thought I had 15 minutes.
No, it's just 10. I'm so sorry.
Oh, well, I wish I had known that. Well, let's just take a good look. Good idea to check your electricity capacity now so you're ready to go when you want to change. I want to point out there's lots of incentives to help you along. Mark is going to talk about that a little bit later. Here's some of the sources. He's going to go over that. Might want to think about delaying your installation so it goes into 2023 because there are some new incentives coming in. I've got some advice on selecting a contractor and then some final thoughts. If I can go through these, I'll then wrap up. Okay, so first of all, it's a good idea, as I said, to get prepared now. So if and when or I should say, when your current appliances go out, you're ready to go. If you go ahead now, you're going to be in an early adopter group, so it's going to be more challenging than it's going to be 5 years from now when the heat pumps are just the standard. But don't let the challenges hold you back. You've got lots of guidance available, and the codes and emission requirements are changing very fast. It's just not fast enough. We need to move ahead now because we don't have time to wait. Thanks a lot.
Thank you, David.
David, thanks so much for sharing all that incredible knowledge on heat pumps. And David is going to drop down into Q&A to answer any residual questions. So please feel free to pick his brain, and we'll try to get answering questions in the Q&A chat as well.